Okay, so the book describes three different types of analytics models. Now, in reality, most systems would actually have a combination of, you know, features from all three of these. So this is the sort of thing which is useful in asking multiple choice questions, but most sophisticated business analytics systems, they will help you understand and explain the data. They will offer you some predictions, and then they will actually, give you some sort of possible decisions or solutions to apply. So a lot of most analytics doesn't really fit into one of these kind of quite narrow buckets. But I'll try and give examples for each. So descriptive analytics, where we're utilizing past business data. This is kind of like a segmentation solution. And this is actually Budweiser in Peru. And it's just like a little data dashboard. And all we're doing here is we're just doing a very simple segmentation. We're splitting usage occasions, like when do people drink Budweiser, and we're also looking at the consumers. If you don't know what this thing is on the left, this is like class-based segmentation. It's not as common in America as other parts of the world. I think it originally comes from the UK, which is maybe why we're kind of obsessed with class in the UK. But generally, like, A's are the top tier skilled positions. Um, B's like managers. C are like skilled manual workers from maybe skilled machinists. And D and E are kind of the unskilled workers. I don't think that sort of segmentation would go down very well in the US. And we're also segmenting on age and gender. And then we're looking at, like, these different groups, and we're going to look at our kind of revenue and profit from each of these segments. So the idea is to identify segments where we're doing well, or maybe identify segments where there's opportunity for us to improve our position in the market. So here's a predictive example. And this is where where they were trying to recommend movies to consumers. And the idea is based on your past movie reviewing and viewing history, we can actually predict which movies you are going to like. We can make recommendations. And this is going back a long time, but Netflix had a challenge where they offered $1 million for the people who could make the most accurate predictions on data. And by accurate predictions, we mean we kind of trained our models on a subset of the data, and then we tested on the remainder of the data. We actually know the answers, but we pretend we don't know the answers. What's known as holdout validation. So we had this challenge was actually quite fun. So we had, I think this was the AT&T team, and this was a father and son at home, like solving the challenge. And one interesting thing found from that is, the best solutions incorporated lots of different analytics models. The final solution had about 100 different analytics models. And generally, most solutions incorporated some sort of like what's called collaborative filtering, i.e., we kind of look at similar movies based on like viewing patterns. We see what you've got for similar movies. So, for example, this is a silly example. We've got Saw 1, Saw 2, Saw 3, Saw 4, and Saw 5. If I'm a teenage male and I love this sort of movies, then I'm probably going to love the next Saw movie. And that's kind of the idea behind collaborative filtering, in that we look at kind of correlations between reviewing patterns, and we find similar movies, and if you've seen similar movies, we look at how you like similar movies if we want to predict how you will like a certain movie. And most of the solutions also incorporated some degree of segmentation. So there may be a group of consumers who like these kind of these films, also I guess known as chick flicks, and they dislike maybe horror films and science fiction. So we can, characterize the consumers and see what sort of movies they like, and again, use this to inform our prediction. So that would be the prediction. In the end, for each movie, we would predict, a review score between 1 and 10. Another type of predictive analytics, class prediction. I predict whether a company is going to be bankrupt or not. I predict whether or not somebody's going to purchase um, my product or not. We can have continuous prediction. I'm trying to predict how much a house will sell for. So there's lots of different, prediction problems where we're trying to make an actual prediction. We can also have prescriptive analytics where we're actually trying to make a course of action. Now, prescriptive analytics, there's lots of different kind of prescriptive types of prescriptive analytics. A very simple one is revenue management, where we run an optimization model and we try and determine how much to charge for a certain plane ticket. This I thought was kind of quite an interesting one because it incorporates, some elements of descriptive analytics, predictive analytics, and then makes kind of prescriptive choices. And this was kind of like an influencer marketing example. And the idea here is that we kind of find people who are influential on certain social media topics. So we look at social media and we look for people, who always gets retweeted, whose post gets liked, who has a lot of friends, what topics do they post on. So these are kind of influencers. And what happened here is we kind of developed this company. This was actually in India. It was an ice cream company called Hokey Pokey. And the idea was to be able to offer, certain coupons, certain maybe free things to these influencers. So we're actually making business decisions. And those influencers would kind of go and post custom ice cream recipes for this ice cream store. So this was kind of a little bit of everything. I've put it down as prescriptive, but it's kind of a little bit of everything. And we're identifying influencers, we're having them make their own custom ice cream, and then we're kind of incentivizing these influencers with maybe coupons or free goods and things like that. Okay, so models, every time we make a model, or any time we make an analytics model, it's not going to be perfect. If it's too perfect, if it kind of like accounts for everything, then it's probably going to maybe overfit the data. So if we think about movie prediction, very basic movie prediction, we want to consider things like, maybe social media buzz, the star power, the production budget, the number of screens the movie is estimated to be shown on. So we might have 5 or 6 useful variables. And we build this kind of simple model. We assume that these are the important variables. But there's probably a lot of other variables out there. There's probably maybe 20 or 30 other variables where we kind of assume a simplified model in order to make our model kind of tractable. And here's an example from the book, and I'm going to go with it because it's actually quite a nice example. And we have it on the spreadsheet. I uploaded this week. And this is kind of very simple. As I increase the price of an object, the demand goes down. So maybe I've got a coat and maybe the value's like, probably about $100. And if it's $80, people think this is really good value. But if it's $120, it's not so good value. So the demand goes down as the price goes up. Very simple model. And we can assume this very simple linear line, this linear demand model. For each increase in price, the demand changes by a certain amount. Or we could have a slightly more complicated nonlinear demand model. So each of these models is kind of a simple modeling of behavior. And we know kind of the price is going to go down. The demand is going to go down as the price goes up. And this is actually from the book, but they say they've actually made a mistake with this slide. And this really shouldn't be thousands of dollars. This should be actually the demand. Maybe I'll email the author. And the idea is we have two kind of competing models. As we go throughout the course, we'll look at how we actually evaluate these models relative to the data. But the idea is we have two models, and the models are probably not going to be perfect. So ideally, when we're building models, we're trying to find the simplest model that most adequately fits our data. Okay, so again, I said models tend to be simplified and they don't tend to be perfect. There's always going to be a degree of uncertainty in the model. We don't know exactly, how consumers are going to behave. I may have segmented this group of blue-collar workers, and we think they have certain views. We think they have certain likes, but we can't be 100% certain. There's always a degree of error in any model. And, there's always a risk that something's going to happen or our model is going to be wrong. So let's imagine we were like trying to predict. We're kind of a restaurant, we own a big restaurant company with thousands of restaurants, and we're trying to predict our sales over time. This is a pretty constant pattern. You can see that maybe the last recession, the growth kind of went sideways. It didn't go down a great deal. And generally, things like restaurant sales are relatively recession-proof, because if there's a recession, people tend to cut back on big ticket items, but often compensate by having a little bit of luxury. So, we didn't have an increase, but the recession didn't have a huge, impact. And we kind of carry on like this. So I can imagine when I'm making my planning for my restaurant about opening new restaurants, how many people to hire, I'm pretty certain about my predictions. But look what happened in 2000 with the pandemic. Something that's not happened for 100 years. And look what happened to my restaurant sales. There is no way I could have predicted that. And that was kind of, a risk that nobody would have really forecast. Okay, so the last little bit, this was in the book. This was probably a little bit dry. So it's kind of this problem structuring approach if you have an analytics problem. And it goes through these stages of recognizing, defining, structuring, analyzing, interpreting, and implementing a solution. But I'll try and do it with my video example. So what's my problem? Well, maybe I have a YouTube channel like the one I showed you before, and it's underperforming. My new videos are not going viral. They're not getting any more users. So what's my problem? So how do we plan YouTube video releases to improve my channel revenue and maybe to help me get more videos going viral? And how do I structure the problem? Well, I begin to think, I've got viewing patterns. I've got patterns of subscriptions, subscribers. I want to look at how these variables are related to the type of content I produce. I want to look at the kind of the content that's been successful. And I want to see how I can maybe produce more successful content. How do I analyze the problem? Well, I may do a little bit of time series analysis to see how the videos perform over time. I might do what I showed you before, a little video analysis of viral behavior using functions. And I might run some sort of regression model relating the video attributes to performance to see, how I can improve my videos, how I can optimize my videos. I would interpret those results. So I'd analyze, which videos go viral versus non-viral. I'd look at my regression results. Maybe certain comedy videos I do better than other videos and bring in more new subscribers. And maybe even I'd look at the type of the videos, what sort of visual features in the videos are related to positive results, positive likes and views. And based on all these results, I'd kind of update my content creation plan, when to release videos, what sort of videos to release, in what order. Okay, so that's pretty much it for this week.